Hi, I'm Prof L and welcome to Chemistry Matters, and today we are doing even more organic chemistry. And we've done some, there's an awful lot to go, but today we are going to be looking specifically at how we name organic compounds, because everything's got to have a name, doesn't it? What I'm going to do, the first thing I'm going to do in order to get you to be able to name organic compounds is I am going to teach you how to count to 10. But I'm going to teach you how to count to 10 in chemistry. Because, as I've probably said before in some of these videos, chemistry has its own language. And in order to understand chemistry, you have to be conversant in that particular language. And this is one of the most important things when it comes to chemistry and talking in chemistry, is naming molecules. And with organic chemistry in particular, an important part of that is being able to, as I said before, count to 10 in chemistry. So let's start. Okay, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is stuff that, dare I say it, you will have to commit to memory. They won't be giving you this on your cheat sheets for exams. You need to know this. So here we go, how to count to 10 in chemistry. 1 is meth, 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. We could go on, but I won't, because that should suffice for naming most organic compounds that you should be coming into contact with, I guess, in your at least undergraduate organic courses, okay? So, how do we use this? What's the point of learning how to count to 10 in chemistry? And the answer is, well, organic chemistry, as we've already mentioned, is all about catenation, is all about carbon forming chains, forming long chains, okay? And this numbering system, this 1 to 10 that we are learning, is all to do with denoting the length of carbon chains in your molecules. So meth, eth, prop, bute, pent. You might think, oh, I haven't seen these before. Well, you kind of have, because you know of a molecule called methane, for example, or methane, depending on your origin, or ethane, or propane, or butane. Okay, that's where those names come from originally. So let's go through and show how we use these in practice. But again, I specify that you are going to need to learn these. Okay, you are going to have to learn 1 to 10 in chemistry. So, you know, make flashcards, write them down a million times, do whatever it takes for you to remember this set of what we're going to see are prefixes, okay? Because that's really, really, really important. Okay, so we're going to get rid of these and we're going to name our first organic compound, okay? So here we go, 3, 4, 5, 6, 7, there we go. There is the line structure of an organic compound. What is its name? Okay, so firstly, and most importantly, I guess, is what's the longest carbon chain in the compound? Okay, that is very, very important when it comes to naming these things. So the longest carbon chain in this compound comprises how many carbon atoms? Right, let's count them. 1, 2, 3, 4, 5, 6, 7 carbon atoms. Okay. So 7 carbon atoms, we are going to use that counting scheme that we had before I rubbed it out, okay? 7, so meth, eth, prop, bute, pent, hex, hept is 7. So an organic molecule that's got a longest carbon chain of 7 is going to have hept somewhere in the name. Okay? There's hept. Now, the other important thing when it comes to naming organic compounds is the type of organic compound that you've got. Now, we'll see what that means in later videos, but suffice it to say at the moment that this particular organic compound only contains carbons and hydrogens, and all of the bonds in this molecule are single bonds. And if that is the situation that obtains, then we're going to have a suffix for our name that is going to be ANE. So hept is our prefix, ANE is our suffix, okay? And the name of that particular molecule is going to be heptane, okay? Now this belongs to a family of molecules called alkanes, and alkanes are composed only of carbon and hydrogen and only of single bonds. And so this is a member of the alkane family. This is a thing called heptane. Okay, what's its chemical formula? Well, we know it's certainly C7. Here's your line structure. You know now from your line structure that these guys, these terminal ones, are going to be CH3s, and the carbons and the kinks are going to be CH2s. And so therefore you've got 3, 6, 8, 10, 12, 14, 16 hydrogens in the C7H16 is the chemical formula of heptane. Okay, right, well this seems nice and straightforward, nice and easy. Let's name a slightly more difficult molecule in that case. So, what would happen if we took that and we did that? Okay, so we've taken that heptane molecule and now we have added a carbon to it. Okay, so what difference does that make? Well, it does make quite a little bit of difference. Quite a little bit, is that proper English? So let's then go ahead and look at this molecule now. Now, again, the same rules apply. We look first. The first thing you do when you're naming anything is you look for the longest carbon chain, the longest chain of carbon atoms. So we've introduced another carbon atom here, so does that make a difference to what the longest carbon chain is? Let's see. We've got 1, 2, 3, 4, 5 going that way. We've got 1, 2, 3, 4, 5 going that way. We've got 1, 2, 3, 4, 5, 6, 7 going that way. And obviously going the other way gives you 7 as well. Okay, so the longest carbon chain here is still 7. Okay, so we are going to have somewhere in our name hept. Okay, now all of the bonds in this molecule are still single bonds. Carbon, hydrogen, and carbon-carbon, single bonds. So that's not going to make any difference to the suffix. Okay, the suffix is still going to be ANE because this is still an alkane. All of the carbon and hydrogens are bonded together by single bonds. But we know it's not heptane by itself because now we've got this extra carbon. So what we do is we include this in the name. Now this is what we call a substituent. Substituent. And a substituent is any non-hydrogen atom or group of atoms that come off the longest carbon chain. That's a simple definition of what we mean by a substituent. Okay, so when we are naming molecules that have substituents, we need to know two things. We need to know, one, what is the substituent? And number two, where is the substituent? So let's work through that now. So what is the substituent? So the substituent, this is a carbon atom, isn't it? And from the line structure, it is bonded to one other carbon and 3 hydrogens. So the substituent here is a CH3 substituent. That's only got one carbon in it. So we go back to our numbering scheme and we say, right, what's the numbering for one carbon? The numbering for one carbon is meth. Okay? And we are going to call this a meth or methyl substituent. So whenever we're talking substituents, you put a YL as your suffix on your prefix, your meth, eth, bute, prop, etc., etc. Okay? Or prop, bute even. So we know we have got, in this case, a methyl substituent. Where is it? Okay, so what we need to do now is we need to number the longest carbon chain. Okay, so let's do that. Let's number the longest carbon chain. We're going to assign consecutive numbers to each carbon in the chain. Here we go. 1, 2, 3, 4, 5, 6, 7. Okay, 7 carbons in the chain. And it looks like our substituent is attached to carbon 4, doesn't it? Aha, but not so fast, you say. Not so fast, because surely you could equally well number the carbon chain from the other end. Yes, you could. So let's do that. Let's go 1, 2, 3, 4, 5, 6, 7, like so. Does it make a difference? No, it doesn't. Okay, that's the beauty of this particular example. It doesn't make a difference, regardless of whether we start numbering from this end or from this end. The substituent is bonded to carbon 4. And so therefore, to include the substituent in our overall name, we then stick it out the front. So our substituent is a methyl substituent, so we're going to put methyl out the front of heptane. Where is it? It is on carbon 4, okay? And so therefore, we are going to say it is 4-methyl heptane. Okay? And that's it. Fairly straightforward, hopefully. Okay, 4-methyl heptane. What is that telling us? What's the information contained in the name? Hept means the longest carbon chain is 7. Ane means that all of the bonds in the molecule are single. Methyl means that we have a methyl substituent, a CH3 substituent, on one of the carbons of the longest carbon chain. 4 tells us that that methyl substituent is bonded to carbon 4 in the chain. 4-methyl heptane. Okay. Happy with that? Right. I'm sure you are. Let's then go for something, again, a little different. Right, 1, 2, 3, 4, 5, 6, 7. Easy to lose count when you're drawing these line structures, and let's do this one now. Okay, continuing on a theme here. Longest carbon chain to begin with. Let's look at it. Right, so we've got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Longest carbon chain, 7. So again, we're going to have hept somewhere in the name. Next thing, all of the bonds are single. So therefore, we're going to have ANE as our suffix. Do we have a substituent? Yes, we do. What is the substituent? This is a CH3. This is a methyl substituent. Okay, so therefore, let's include that in the name then, methyl heptane. And the last thing that we're going to have to do is say, right, where is the substituent? Where's it located? And here is where things get a little bit interesting. We know it's off the longest carbon chain. What carbon is it attached to in the longest carbon chain? Let's number the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. But again, you say, right, can we number it from the other end? Yes, we can. Does it make a difference? We'll see. So we go 1, 2, 3, 4, 5, 6, 7. And we see in this case, yes, it does make a difference. And so therefore, When we number the longest carbon chain, from both ends, there is a difference. And whenever there is a difference, what do? We give the substituent or substituents the lowest possible number, or numbers, as we will see, okay? So in this case, the numbering in red gives the substituent as being 5 on carbon 5. The numbering in black gives you the substituent as being on carbon 3. 3 is going to win over 5 because it is less, so therefore we are going to call this particular molecule 3-methylheptane, or 3-methylheptane, okay? So that's another rule. The substituents get the lowest possible numbers, okay? Right, so let's do another one or two, just to make sure that you're getting all of this. Okay, so bam, 3, 4, 5, 6, 7, and we will go bam, bam, like that. So what's this one named as? Okay, so hopefully we're getting used to this now. Let's go and find that longest carbon chain. What do we got? We've got 1, 2, 3, that ain't gonna be that. 1, 2, 3, 4, nor that. 1, 2, 3, 4. So you've got to look at all of the possible carbon chains in this thing just to make sure. 1, 2, 3, 4, 5, 6, 7. Yep, that's 1, 2, 3, 4, 5, 6, 7. Ooh, okay. We've got 2 carbon chains, 2 longest carbon chains. We've got 1, 2, 3, 4, 5, 6, 7. We've got 1, 2, 3, 4, 5, 6, 7. How do we get around that? The answer is we don't have to. We don't even have to bother about it because it takes care of itself. That's going to be all good. So, longest carbon chain is 7. 1, 2, 3, 4, 5, 6. Just checking on that one. Okay. Longest carbon chain is 7, so it's going to be some sort of hept. Do we have any double, triple bonds here, or are they all single? They are all single, so we're going with the ANE suffix here. Now, do we have any substituents? Yes, we do. And in fact, we have 2 substituents. We have a substituent here, which is a CH3. We have a substituent here, which is also a CH3, isn't it? Now, hold that thought, because when we say that this is a substituent, we're saying that that is the longest carbon chain. But what about if we're saying that this is the longest carbon chain? Because they're both 7. 1, 2, 3, 4, 5, 6, 7. If you use this as the longest carbon chain, you've got a substituent at carbon 2 and carbon 3. If you use this as the longest carbon chain, you've got a substituent at carbon 2 and carbon 3. It's the same. Okay, so that makes life a lot easier. So we don't even have to worry that there are 2 carbon chains of 7 carbons long, okay? This all comes out in the wash, as we say, okay? So, what substituents do we have? We have a methyl and a methyl. 2 methyls or dimethyl, okay? 2 methyls, we call it dimethyl. If we had 3 methyls, we'd call it trimethyl, etc., etc. Where are the substituents? Well, again, we go through when we do our numbering. 1, 2, 3, 4, 5, 6, 7 numbering in black. We can go to the other end and do 1, 2, 3, 4, 5, 6, 7. We could do that. Numbering in black gives your substituents the numbers 2 and 3. Numbering in red gives your substituents the numbers 5 and 6. Okay? So therefore it's looking very much like 2 and 3 are going to win out. 2, 3 hyphen dimethylheptane. But not so fast, you say. What happens if you do use this other chain? Let's show that it gives you the same thing. And in order to do that, we only have to change one piece of numbering. We're going to call that either 7 in red or 1 in black. And if we do that, you can see that you get the same thing, okay? If we're numbering in black, the black chain, 1, 2, 3, 4, 5, 6, 7, we have a substituent at carbon 2 and a substituent at carbon 3. In the red numbering, we have 1 at 5 and 1 at 6. Same thing. So regardless of which of the longest chains you use, you still get the same answer, 2,3-dimethylheptane. Okay, right, that, my friends, is an extraordinarily crash course in the very, very simple naming of hydrocarbons that all contain single bonds. As I alluded to, they're called alkanes. We're going to see more about alkanes in the next video, and hopefully I will see you there. Take care.